A gap option is another kind of exotic option. And a gap option is an option which has two strike prices, one determining if a payoff is made and the other one determining the value of the payoff. So in a sense, if you think of a vanilla call, the K serves two purposes. One is the payoff, or the strike price K, determines the cutoff, which defines when a payment is made, and then secondly, it defines the dollar amount of the payoff. In a gap option, one separates those two functions, namely the strike, which defines when payments are made, and then secondly, the strike, which determines the amount of the payoff. So these two strikes are called K1 and K2. And so a gap call pays S minus K1 as long as S is bigger than K2. So if K1 and K2 are the same, then it's a vanilla call. A gap put pays K1 minus S as long as S is less than K2. Now, the interesting thing about gap options is because the Ks can be different, the payment to the holder can be positive or negative. We'll see that in a minute. But because the payment can be negative, the exercise of gap options is required. It's really not an option in a sense. It's a required payment. And sometimes the holder will be paid a positive amount, which is the typical option. Sometimes the holder will actually have to make a payment. So it's not an option at all. And one can predict when that happens. If the stock price is in between K1 and K2, the payment will actually cost the holder money. And similarly, if the stock price is between K1 and K2 for the put. So let's look at a couple of graphs. Here's a simple graph, namely where K1 is 90 and K2 is 100. Now, a vanilla call would have 90 used in both places. If the stock price is bigger than 90, a payment to the holder is made of S minus 90. But here, in a sense, compared to a vanilla call, the long position forgoes these payments. Consequently, one would expect that this option is cheaper than a call option with a strike of 90, because the long position is foregoing these other payments. The next is a case where it becomes apparent that the payment to the holder can be a negative number. So here I have K1 is 90 and K2 is 100. So we see, and here's 90, we see that in fact this option, quote unquote, costs the holder money if the stock price is in between 100, which is K2, and 90, which is K1. A plain vanilla put would make a payment of 90 minus S, but only when S is less than 90. So you can also, as an exercise, develop an example like this of a call option, which will cost the holder money, or you can develop an example of a put option whereby if here K1 is less than K2, you can imagine a put option where K2 is in fact less than K1. And it'll be a truncated put, much like the truncated call we looked at a minute ago. Turns out the value of gap options can be calculated using a variation of the Black-Scholes formula. Namely, where K1, which serves the purpose of the payoff function, K-off is the strike that defines the payoff, is used in the usual Black-Scholes formula, and K2, which determines when a payoff is made, enters into the D functions. And this is logical if you think about those two purposes, that the D functions determine when payments are made, so they should reflect K2, And the coefficients of these normal distributions reflect what the payments are, the exchange of payments are, and namely S for K1. And there's a comparable formula for a put. So here's an example of some gap option prices, and we notice for the first time in all of our option tables that we have some negative prices. This is because in these cases, these are not truly options. And we can do an example in just a moment to make sure we understand this. So what is this? This is, again, a put option on a euro. The initial exchange rate of the euro is 90 cents, all the usual parameters we've seen in other examples, and it's a half-year put. And so these are the Black-Scholes put prices. So for different strikes, K1, which would be the K in Black-Scholes, we have a strike of 80, which is an out-of-the-money put, 90 and at-the-money put, and a $K, that's an in-the-money put. Logically, Black-Scholes prices increase, as do all of the prices, because, again, as K1 increases, the moneyness of the option increases. But let's investigate further why, if K2 is $1, why, in fact, it seems logical that if I go long this option, I will be paid to do so. Somebody will pay me almost 9 cents to be long this option.